Well, in this last segment of the workshop that I'll be presenting, I want to focus in first on tribe Madieae, which is the tribe that I've primarily focused on in my research during my career, and which we're continuing to study, including an ongoing study of target-enriched nuclear data that we're still analyzing. I hope to share with you in the future. This is a group that includes a little over 200 species, but that number really belies the incredible morphological and ecological diversity that exists within this tribe, including characteristics that you wouldn't necessarily imagine in one tribe. This is a group that breaks the rules in terms of composite evolution in some regards, and so the circumscription of the tribe currently is not comparable to past circumscriptions prior to around the turn of the last century, around 20 years ago. And we've learned a lot about the evolution from molecular phylogenetic studies. Like the Cunactidae and the Madieae, this is a group that's primarily of northerly origin within the New World. And in fact, most of the diversity in the Madieae can be found in California, at least with regard to the diploids. So this is a group that's diversified a lot in western temperate North America. So the bulk of the diversity within tribe Madieae falls within the subtribe Madieae, which is a subtribe that's been long recognized. And it's been commonly treated in the Helianthae tribe, but it's been moved around in different tribes over the years because, as I mentioned, it does have diversity of characteristics that have commonly been used to circumscribe higher level groups. And these so-called tarweeds, the members of subtribe Madieae, about 24 genera, around 120 species or so, are plants that have some really distinctive morphological synapomorphies or diagnostic characteristics. So all the tarweeds that have radiate heads, that have ray flowers, have a one-to-one relationship between the ray ovary and the filary or involucral bract. As you can see in these diagrams, the filary basically subtends and surrounds to at least some extent the ray ovary, clasping it, and the filary plus the ray fruit together form a dispersal unit. And the filary commonly has glandular exudate on its abaxial surface, or it may have hooked hairs in a few instances that allow for animal dispersal of the ray ovaries, the ray fruits. And the different major clades of tarweeds can be distinguished in part by whether or not the ray fruits are compressed or obcompressed, sometimes terete. As you can see in these diagrams, there's quite a lot of variation in the amount and direction of compression of the ray fruits. Also, when we look at the receptacle, there are Perityleae in all of the tarweeds, that is, members of subtribe Madieae, but in most members, the Perityleae or receptacular bracts are peripheral. That is, they're located only around the periphery of the head, between the ray flowers and the disc flowers, forming a ring, basically subtending the outermost disc florets. That's the condition you see in illustration A here. Whereas in a minority of species, the Perityleae subtend each disc floret, just like we saw in some of the primarily palliate tribes, like Helianthae, Malariae, Coreopsidae. And so the tarweed condition A here is very diagnostic for the subtribe, and as are the clasping filaries. But this only really works for members of the subtribe that have radiate heads. There are discoid-headed species, and these lack both filaries and ray flowers, with the peripheral ring of Perityleae basically forming a false involucre. And in those groups, there's been a lot of confusion about their relationships. They weren't realized to be tarweeds until relatively late with the work of Sherwin-Carlquist, who got into other aspects of the anatomy. And here you can see just a summary diagram with some sampling across the subtribe Madieae in tribe Madieae, these various tarweed groups, and these major lineages that I mentioned that can be diagnosed in part by the degree and direction of compression of the fruits of the ray florets. And here you can see exemplars of these major lineages within the group. And these are genera and basically groups of genera that had long been recognized to be part of the tarweeds. But the molecular phylogenetic data were brought to bear on a hypothesis of Sherwin-Carlquist, that is, that the tarweed subtribe not only includes these California tarweeds, but also the Hawaiian silver swords and relatives. And the molecular data showed that the Madieae lineage down in the lower right, was more closely related to the silver swords and relatives of the Hawaiian Islands than to the Leas, for example, in the upper right panel here, which are often confused for Madieas. So this is a case of accelerated morphological and ecological evolution in the insular environment where members of the subtribe Madieae had dispersed from Western North America, underwent an adaptive radiation where we see basically a tremendous diversity in life forms, including rosette plants, both fleshy-leaved in the case of R. gyrosiphium, the true silver swords and green swords, fibrous-leaved rosette plants in the case of Wilkexias in the far left, and then these other representatives are in the genus Tribatae, trees, shrubs, lianas, mat plants, cushion plants. So a lot of diversity occurring across the environmental spectrum in Hawaii. And we've done a lot of work and continue to on the diversification of this Hawaiian clade. So in addition to understanding the relationships within Madieae, we've also been interested in how the Madieae is related to other composites. And that's what really began this overall study of the Helianthe Alliance, to try to get a handle on what the Madieae might be related to, because there were a lot of ideas out there, but nothing very solid. And it turned out, after extensive sampling, that the tarweeds, the subtribe Madieae of Madieae, were more closely related to the genus Arnica, this medicinal circumboreal genus, than to anything else. And so Arnica forms one of the other subtribes, the subtribe Arnicinae of Madieae. This is quite a surprising finding. Arnica had long been placed in the Senecio. It has a bristly pappus, which, as I mentioned earlier, has created a lot of confusion about relationships. And interestingly, the genus Railardella, only 3 species, mostly Californian, all found in California, like Railardella pringleii here on the right, also had been placed in Senecio. And Arnica and Railardella had long been placed together because they both have opposite leaves, which a very unusual feature in the tribe Senecio. But Sherwin-Carlquist back in the 1950s recognized Railardella as a tarweed and placed it in the subtribe Madieae with the other tarweeds. What we found now is, well, in our research history here, was the Arnica is sister to all the tarweeds. So these traits that Arnica and Railardella share seem to be ancestral to the tarweeds as a whole. And this is largely high montane occurrence, or in the case of Arnica, even high latitude occurrence. But most of the Arnicas that are diploids are found in high montane situations and further in lower latitudes of temperate North America, including California. And also some of these other features of the ecology occurring in somewhat wet environments seems to have been ancestral, with most of the tarweeds actually being in xeric settings. So moving out of montane settings that are relatively cool and moist into drier settings seems to have been a theme within the Madieae, at least with regard to the tarweed origin. And what we also found was that there were a bunch of taxa, that genera, that had previously been called arnicoid by some people, all with X equals 19, a chromosome number based on 19 pairs, the highest chromosome number in the tarweeds being only 17 pairs in Raylardella, which comes out in the phylogenies as sister to the other tarweeds, or close to a basally divergent position. And like Raylardella, these arnicoid taxa tend to be perennial herbs, so annual habit seems to be derived in the tarweeds as well. And here you can see some of these genera like Holsia and Venegasia that are perennials of moist situations, often montane. The woolly sunflower subtribe Barianae also proved to be part of Madieae. And one of the genera that we erected within that group, Constantia, that didn't turn out to be part of Eriophyllum after all, also has 19 pairs of chromosomes like these arnicoid genera, and is basally divergent within the Barianae, presumably plesiomorphic similarities with regard to some morphology as well, such as perenniality and the moist conditions that it occurs in the Channel Islands of Southern California. So we have in the Barianae as well an example of a likely perennial ancestry with a derived annual state. The woolly sunflowers are also mostly Californian, like the tarweeds, and often have woolly foliage with a 1 seriate involucre, with a 1-to-1 correspondence between ray flowers and filaries oftentimes. Within the woolly sunflower subtribe Barianae, we have Variopsis, a monotypic genus endemic to Guadalupe Island, 150 miles off the coast of Baja California in the Pacific, and it proved to be nested among other members of Barianae like Lasthenia, and appears to be a derived perennial from an annual ancestry. We also see this with regard to Lasthenia, Ornduffii, and some other coastal Lasthenias that are nested among annuals. So there have been multiple origins of maritime perennial herbs from annuals within the Barianae. And in both the Barianae and the Madieae, these two of the subtribes within tribe Madieae, we apparently have an incredibly steep descent in chromosome numbers by descending disploidy from a basal X equals 19 condition to chromosome numbers as low as N equals 4 in Holocarpa and Calicodenia of the California tarweeds, subtribe Madieae, and chromosome numbers as low as 3 pairs in Pseudobahia of the woolly sunflower subtribe Barianae. So extreme disploid chromosome number reduction has happened here, associated with this transition to annual habit and occupancy of these dry environments. And more support for Stebbins' idea that I mentioned earlier of selection for lack of recombination in these dry habitats where there's very little wiggle room in terms of phenotypic expression that annuals can express without falling outside the range of survivable phenotypes. So finally, I want to conclude by talking about the tribe Perityleae, which is a group of only about 7 genera, 84 species, but it has the distinction of being the sister group to the incredibly diverse tribe Eupatoriae. So I thought I'd end with it, since Ed will be picking up with the Eupatoriae here shortly. So there's a huge disparity in the diversity of these two tribes. And based on the position here of the other tribes within the phylogeny as well, Eupatoriae appears to have undergone some accelerated diversification. Perityleae in itself is a very interesting tribe, and this constitutes the rock daisy, or comprises the rock daisies, which are a group that my graduate student, Isaac Lichter Mark, is concluding his PhD on this summer and has done a really amazing job of working out relationships and evolutionary and ecological histories for these various clades. These rock daisies are well named because they occur on bedrock surfaces, often on cliff faces, and show an island-like distribution through the desert southwest associated with the orogeny of those ranges, and really exemplify a group that's diversified with the origin of sky islands through the desert southwest with an ancestry in the subtropics. And there are representatives here of various genera are shown. Isaac's in the middle of a major taxonomic revision of this group. But the overall circumscription of the tribe remains as proposed back in the early 2000s. And there are some nice features like four-lobed rather than five-lobed disc corollas, and fruits that are compressed and ciliate usually, and filaries that are usually boat-shaped or navicular in this group, which includes both radiate and discoid members. Nezothamnas is a genus that he's resurrecting from Guadalupe Island, which is one of the most remote parts of the California floristic province with a Mediterranean climate off the Pacific coast of Baja California. This particular species has been traditionally treated in Perityleae as Peritylean canna, but Nezothamnas is an old genus that is worthy of resurrection based on the molecular phylogenetic results. So in conclusion, Heleniae in the broad sense, in the old sense, including these various E-palliate tribes we've talked about today, and Helianthe in the broad sense that included all the diversity we're talking about, except Eupatorii in its broadest circumscription in the past. Neither of them were monophyletic in previous circumscriptions, but each comprises major natural groups or clades that are now treated as tribes, a system of 15 tribes. There have been multiple shifts between palliate and E-palliate conditions. Pappus evolution has been even more highly dynamic, however, and has been part of the reason that there's been such misunderstanding of relationships within this set of tribes overall. Disploidy and bidirectional shifts between perennial and annual habits have been common within the Helianthe alliance and been subjects of a lot of interest with regard to evolutionary change. And long-distance dispersal, particularly to oceanic islands, has been of great interest to us within this clade. There have also been some other instances between continents, a really fascinating set of examples for studying insular evolution. And finally, retention of Eupatorii does require the recognition of multiple Henioid and Helianthioid tribes, and I hope I've given you some appreciation for some of the characteristics of those groups today. And Ed will pick up at this point now with the Eupatorii, which definitely deserves a major treatment. Okay, well, it's been a real pleasure. Thanks very much for your attention.